Dengar tak?
Dengar tu.
Dengar.
Okay. Okay, Assalamualaikum warahmatullahi wabarakatuh and good evening. So for this class, we are going to learn new chapter 4, Fourier transformation. So I think this chapter only 2 weeks we will finish lah. By 2 weeks we will finish this chapter. So chapter number 4 is called Fourier transform. So in this chapter, we only have 3 subtopics. The first one is the introduction to what is a Fourier transform. And then we have the even, odd, and neither function. And lastly, we are going to form a Fourier series for any given periodic function. Alright, so let's introduce to you what is a Fourier function, Fourier series. So this series is named accordingly to the contribution done by John Baptist Joseph Fourier, 1976 to 1830. Salah tahun ni salah. 1776 Dia lahir kemudian dia mati dulu Okay, so what is a Fourier transform? So Fourier transform is a trigonometric series to solve a heat equation in metal plate. So this man developed the theory of heat conduction, making this series a most important tool in applied math. So Fourier series actually is one of method to solve the heat equation, and I think you also will learn and will use this Fourier series in order to solve the heat equation later on in your engineering class. I'm not sure which class or which course that you will use, and of course you will learn the Fourier equation. I think it's about the heat transform lah, heat conduction, not a Fourier equation. Fourier's law, I think. Yes, Fourier's law. So to solve the Fourier's law equations and heat equation, so you need to know the Fourier series. So Fourier series is an expansion of periodic function in terms of an infinite sum of sine and cosine. Fourier series make use of the orthogonality relationship of the sine and cosine function. So actually Fourier series is a expansion of periodic function where you transform from one periodic function to a new function consists of sine and cosine only. And you use the Fourier series to solve the heat equation, where the heat equation actually one of the differential equation, or heat equation actually one of the partial differential equation. So when we talk about periodic function, so what is a periodic function? Let's say we have one function, we call that function ft. So this function ft is defined for all t. So when we say t, let's put t as a variable, whether you want to use t or you want to use x. And this function defined for all x. Let's say x from negative infinity to positive infinity. So when we say about periodic function, the periodic function, we said that function is periodic if there exists a positive number p such that f t plus p equal to ft for all t. So this function is called periodic after some number p. When we arrive at t equal to p, the function are just same with ft. Then the number of p is called the period of function f. Fourier series is used in the analysis of periodic functions. So let's see figure 1. So this figure 1 show an example of periodic function. So let's observe this function. Actually, this is a sine function. So this is a function of sine x, where x we define from negative pi, negative infinity to positive infinity. So x is defined for all these intervals. So when you take a calculator, for example, or you have a graphic calculator, you put x equal to 0. So when you put x equal to 0, you will get here. And then you put x equal to 1 radian, you get this one, 2 radian, 3, 4, 5, 6, 7, up until pi. So from 0, you put 0, you will get up to here is pi. And then you continue again. So when you try to plot, lastly, it forms this function. So now you have already plot from 0 to 2 pi. So when you put another increasing x, for example, x equal to 2.1 pi, for example. So now you observe that this function repeating again the same function that we plot earlier. So this is one function you plot from 0 to 2 pi. So this one from 0 to pi you get from here up to here. After 2 pi, when you try to plot again, you get the same function. Now you can observe this one and this one from here to here are just the same. So from 0 to 2 pi, we call this one is a period. So this sine x, we call the period is equal to 2 pi. Why the period is equal to pi? Because this function will keep repeating the pattern for every 2 pi. So after 2 pi, the function will keep repeating again the same function from 0 to 2 pi. So if you try to plot, then from negative, you try to plot, then you get the same shape. So it has the period of 2 pi. So this one we call a periodic function. Alright, now let's move to 4.2 determination of even, odd, and neither function. So before we discuss further in Fourier series, this is also one of the important term in Fourier series. A function can be said even function, odd function, and neither function. So first, let's see what is an even function. So a function of x, fx is said to be an even function if f negative x equal to fx for all values of x. So you have a function fx. Now, when you try to substitute x with negative x, so you take for all x, you put negative x. And then you observe whenever you put negative x, the function give you just the same value with positive values. So you put negative x, you get same with fx. So this one we call the even function. So please remember this one. So this one is very important, how you can identify whether the function is even or odd function. So when you substitute x with negative x, you will get it is equal to fx. So when we try to plot an even function, so the graph of an even function is always symmetrical about y-axis. So now let's see this graph. So this is this is y-axis and this is x-axis. So this function is x squared. So we try to plot x squared from -2 to +2. And then we observe that x squared is shaped like this. So let's try to prove this theorem. F negative x equal to fx. So now let's say x equal to 2. So this is x equal to 2. So when x equal to 2, you find that fx equal to 4. So when x equal to 2, fx equal to 4. Now you substitute x with negative x. So you take -2. Now let x equal to -2. And you observe that our fx also equal to 4, this value. So this one and this one are the same. So we have proved that for even function, the function is fulfill this theorem. F negative x equal to fx. And when we try to plot, the graph is always symmetrical about y-axis. So now you observe that this is y-axis. So this graph is symmetrical to y-axis. So when you try to draw the other half, it is a symmetrical. Dia sama, it is like a mirror image. So observe that, let's say this is a mirror. So the image on the left hand side are equal to the image on right hand side. So whenever you try to draw the graph about even function, it is symmetrical about y-axis. It looks like a mirror image. For odd function, when we substitute x with negative x, we observe now that the function is equal to negative fx. So this one. So it is quite different from even function. Even function, when you substitute negative x, you get positive. Now, for odd function, you substitute x with negative x. Next, with negative x, you get negative fx. So now, the positive value of fx became negative value of fx. The graph of odd function is always symmetrical about origin. So this is origin. So when we say the symmetrical about origin, it means that if you try to rotate 2 times, it will be symmetrical. Let's say the graph on the right hand side here. So if I try to rotate 1 time, I plot the mirror image of this right hand side, I will get this one. And then I rotate 1 more time, so I get this one. So now the new graph is this one. So that's why we call a symmetrical about origin. It rotates 2 times. So whenever you substitute x, let's say this is x equal to 2, fx equal to 7, x equal to 2, fx equal to -9, positive 9. So when you substitute here, you get the negative fx. So when you substitute x equal to 2 here, so you get negative fx here. So this graph is about x to the power of 3. So when x equal to 2, you get 8. When x equal to -2, you get -8. Lastly, what is a neither function? A neither function is a function which have no such symmetries. For example, it is neither odd or even. So neither function is a function that is not even an odd function. So when you try to substitute negative x, you will get this function not equal to fx or not equal to negative fx. So that is a neither function. Example of neither function. One example of neither function is exponent x. So when you try to substitute negative x, so f negative x, so here you will get exponent negative x. So this one is not equal to fx because our fx is this one. And this one is also not equal to negative fx. So if I put negative fx, it is negative exponent x. So this one is not even function and this one is also not odd function. So if I try to plot the graph of exponent, so let's say this is x, this is fx. So if I try to plot the graph of exponent, I will get this one. And if I try to plot on the left hand side, negative side, I also not get the same value as this function. So the graph is goes like this. So this is neither function. Let's see what is this one. Cos x is always an even function. So whenever you have a function consists of cos x, it is always an even function. So whether you put cos 2x, cos 3x, cos 4x, it is always even function. If you try to plot the graph, so this one, you see that the left hand side, the right hand side here are symmetrical with the left hand side. Sin x with odd function, sin x with odd power will always be an odd function. So when you have sin x or you have sin x to the power of 3 or sin x to the power of 5. So sin x to the power of 3 is sin 3x, sin x to the power of 5 is sin 5x. So all of these will be always odd function. For example, this one, sin x, sin 3x, sorry, sin to the power of 3x, sin to the power of 5x. So it always represent a odd function, an odd function. While sin with even power will always be even function. So when you have sin square x, sin 4x, sin 6x, it always be even function. For example, this graph. So this graph is a sine square x. This one. So sine square x, when you try to plot the graph, you will get that the left hand side, the right hand side is symmetrical with right hand side. So it is symmetrical about y-axis. So this one is an even function. Let's see example 4.1. Determine whether the following function are even, odd, or neither function. So the first one is cos 2x. To pick fx equal to cos 2x. So how to determine whether cos 2x is even or odd function? So you have two things you can try. First one is using the formula f negative x equal to fx or f negative x equal to negative fx. And this is first method. Second method is either you try to draw the graph. So for this exercise, this example, we try to use the formula first. All right, let f negative x, substitute all the x with negative. So now you have cos 2 times negative x, so negative 2x. And if you try to use your calculator, you find that f negative x is same with cos 2x. This one, the value are equal. You can confirm with your calculator. If you're not sure, you try just put one number. First, you try to put cos 2, and then you try to put cos negative 2. And then you find that this one are equal, just equal. So we fulfill this one. So we have f negative x equal to fx. So we make a conclusion. This is even function. So this is an even function. But for b, so b we have sine sine 3x. So sine 3x. fx equal to sine 3x. So we try to put negative x. So this one will become sine negative 3x. So sine negative 3x just equal to negative sine 3x. And this is equal to negative fx. So we make the conclusion, since f negative x equal to negative fx, so this is an odd function. So this is odd function. Right, for C, sine square 2x. So fx equal to sine square 2x. So we try to put negative x here. So we get sine square negative 2x here. Where sine negative 2x here is actually equal to negative sine 2x with the power of square. So this one are equal to sine square 2x. And this is equal to fx. So since f negative x equal to fx, so we make the conclusion this is the even function. So you need to do the conclusion whether this is even or odd function. But for D, so D is exponent negative 2x. So fx equal to exponent negative 2x. So let's put negative x. So f negative x equal to exponent negative 2 equal to negative x. And this one equal to exponent 2x. And exponent 2x, this one are not equal to fx. Not equal to fx, where our fx is this one, exponent negative 2x. And this one are also not equal to negative fx. Hence, we make the conclusion this is a neither function. So this is not equal to fx and also not equal to negative fx. And the conclusion is this is neither function. All right, for E is fx equal to exponent x squared. So this one is quite different from the previous one. So let's try to substitute negative x. So here we have negative x squared. So from here we get this one negative square will cancel out. So this one is equal to x squared. And this one fx equal to x squared is just represent this one, just like exponent x squared. So this is equal to fx. Since f negative x equal to fx, so this is the even function. All right, for fx equal to x minus x cubed. So let's substitute x with negative x. So here we have negative x minus x cubed. So negative x will be negative x minus x cubed will be negative x cubed. So if I open the bracket, I get negative x plus x cubed. X cubed. And this is just the same as negative fx. So if I put negative here, if you're not sure, fx equal to x minus x cubed. If you put negative here, so here also put negative, so negative x plus x cubed. And this one and this one are equal. This one, so this is equal to negative fx. So this is even, sorry, this is odd function. So this is odd function. All right, for G, so for G we have fx equal to 4x squared plus 2x to the power of 4. So let's put f negative x. So we have 4 negative x squared plus 2 negative x to the power of 4. So when we have a square, we have 4x squared. Here we also have 2x to the power of 4. And this is just the same as fx. So conclusion, this is even function. Lastly, h, we have fx equal to 2x squared minus 3x plus 1. So let's put x as negative x. So we have 2 negative x squared minus 3 negative x plus 1. So we have here 2x squared. Here we have plus 3x plus 1. And is it equal to fx? No, not equal to fx because fx here we have negative, here we have positive. Is it equal to negative fx? So if I put negative fx, I should have 3x plus 1. So I should have negative 2x squared plus 3x minus 1. So not equal to fx. So this is not equal to fx and also not equal to negative fx. Hence our conclusion, this is neither function. So this is a neither function. Properties of even and odd function. So if we have a function and then we multiply together. Now let see what is the properties when you have two different functions multiply and add together. The first one, if we have a function, the first function is even, multiply with also even function, and you will get the even function. So you just like remember like positive and negative. So even function is a positive, so positive multiply positive, you got positive. So even multiply even, you get even. So positive multiply positive, you get positive. Odd function multiply odd function, you get even function. So negative multiply negative, you get positive. Even function multiply odd function, you get odd. So positive multiply negative, so you get negative. Odd function multiply even function, you get odd. So negative multiply positive, so you get negative. So just remember this one. Now, this one is a product. So this is a product. Product means you have function 1 multiply function 2. Now, let's say you have a addition and subtraction. So if you have from function 1 plus or minus function 2. So if you have even function plus even function, you will get also even function. And if you have odd function plus or minus odd function, the result is odd function. So you get negative plus or minus negative, you get negative number. Positive plus or negative number, you get positive number. If neither function plus odd function, so this is either neither function also. Right. What happen if you have neither function multiply even function? So neither function multiply even function, you get neither function. Neither function multiply odd function also, you get neither function. So neither function is special. If you add or if you multiply neither function with any even or odd function, you will just get the neither function. So now we will use these properties to solve this example. Determine whether the following function are even, odd, or neither function. So the first one, we have fx equal to cos 5x multiply sine square x. So the first one, we have fx equal to cos 5x multiply sine square x. So just remember that any cos function, this is even function. Cos function for all positive or for all odd or even powers, always even function. And sine square, when the power is 2, this is even function. So even function multiply even function, you will get even function also. So even function multiply even function, you will get even function. So follow these properties, this one. Even multiply even multiply even, so you get even. Can we use the method of substitute x with negative x? Yes, we can use method. Let's try. F negative x will become cos negative 5x multiply sine square x. So sine square x actually is sine negative x multiply sine negative x. So to get sine square is you multiply sine x and sine x. So now we substitute x with negative x. So cos negative 5x is same with cos 5x. Sine negative x, so you will get negative sine x And then sine negative x also you get negative sine x. Negative multiply negative will be positive. So you get this one as cos 5x multiply sine square x. And this is equal to fx. So yes, this is a even function. So you still can prove this way, this method. But if you know this one, know the properties of cos. Cos is always even function. Sine function depend on the power. If power is even, then it became even function. If the power is odd function, then it became odd function. So by using the properties, just simple calculation, you can determine whether this is even or odd function. All right, let's try B. So B is fx equal to 4x plus 7 sine 4x. All right, sine, first we determine the function 4x plus 7 first. So if I try to find, let's say this one f1 equal to 4x plus 7. So if I try to put negative x, I get 4 multiply negative, so negative 4x plus 7. And this is not equal to fx, also not equal to negative fx. So this is function f1x is neither. What about function 2? Function 2 is sine 4x. So the power is 1. So sine with odd powers will be always odd function. So this one is odd function. This is odd function. So we have neither function multiply odd function. So this product will always be neither function. So this is a neither function. So the result is neither function. Alright, let's try C. C we have fx equal to exponent negative x multiply x squared minus 1. So for first function, f1, this is equal to exponent negative x. So let's put negative x. So f1 negative x, this is equal to exponent negative negative x. So this is equal to exponent x. So this is not equal to fx. And this is also not equal to negative fx. So for f1, this is neither function. Actually, I can just stop here because I know this one is neither function. Neither function multiply either odd or even function will just resulting neither function. But to to complete this solution, let's do for f2x also. So f2x is x squared minus 1. So let's substitute with negative x. So we get negative x squared minus 1. So this is just x squared minus 1. And this is equal to fx. So this is even function. So neither function multiply even function, we get neither function. So the result is neither function.
Sir,
And let's do for D.
so
So D we have fx equal to 2 sine 3x cos 2 sine 3x cos 2x plus x cubed. Alright, so 2 sine 3x. So function sine, this is a power odd. This is always odd function. Cos function is even function. So this one odd multiply even. So the product is odd multiply even function. The product is always odd function. And x cube here, x cube is odd function. So odd function multiply odd function. So you get the, sorry, this one is plus, right? Odd function plus odd function. So you get odd function. How I know x cube is odd function? So let prove. So let fx equal to x cube. F negative x is negative x cube. So this is just negative x cube. So this is equal to negative fx. So this is odd function. For the e, so we have fx equal to x cube sine 2x. So x cube is odd function. Sine 2x is also odd function. So you must remember sign with the odd powers will be always odd function. So odd multiply odd, so you get even function. For f, so we have fx equal to 5x minus 8x cubed cos x. So let's say this is f1x. So f1x is equal to 5x minus 8x cubed. So f1 negative x is 5 multiply negative x minus 8 multiply negative x cubed. So we get negative 5x positive 8x cubed. This is equal to negative fx. So if I just put here negative fx, if I compute here, if I put negative here, so we get this one. So this is odd function. And cos function, cos is always even function. So odd function multiply even function, the result is odd function. So this one is odd function. F is odd function. All right, so this is the exercise in problem 1 to 10. Determine whether the function is even, odd, or neither function. So the first one you can determine. This one, sine is always odd function. Number 2, x multiply cos. So f1 fx equal to x is I put f negative x. So here will be negative x equal to negative fx. So this is odd function. Cos is even function. So odd multiply even. This is always odd function. Right, number 3, x square plus x. So number 3, fx equal to x square plus x. So find when you substitute negative x, so you get negative x square plus negative x. So you get x square minus x. So x square minus x not equal to fx, also not equal to negative fx. So this one is neither function. So this is neither function. Number 4, fx equal to x cubed minus 4x. So f negative x equal to negative x cubed minus 4 negative x. So negative x cubed plus 4x. So this is equal to negative fx. So this is odd function. So this is odd. Number 5. So number 5, fx equal to exponent modulus x. So number 5 here, fx equal to exponent modulus x. So f negative x equal to exponent modulus x. Modulus will provide you always positive. So this is equal to just fx. So number 5 is even function. Number 6, exponent x is neither. This one is also neither. So the product is neither function. Alright, so I hope when you at hostel you can try the exercise number 2, and then for the next class we will continue the lesson with example 4.3 to determine the graph by using the to determine the function by using the graph, whether it is even, odd, or neither function. So ada soalan tak? If you have any question, you may ask me in the WhatsApp group. So if not, then we can dismiss the class. So before we dismiss the class, let me share the attendance for today. So please fill this attendance. And then for the quiz 2 for tonight, we start at 8:30 p.m. sharp. If you open late, then you will have not enough time lah. The quiz is just for 30 minutes only. The link will be closed at 9:10 p.m. We have extra 10 minutes to complete everything, so you must complete before 9:10 p.m. If you found error, log in again, then you may continue, but no time, extra time is provided to you within the time given between 8:30 to 9:10 p.m. only. Alright, so good luck for your quiz 2 tonight. With that, I dismiss this class. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Waalaikumsalam. Thank you, sir.
Thank you, sir.